Hi everyone, my name is Yutong Yang and my advisor is Winston Ho. My research topic is amine-containing mixed metric membrane for CO2 separation. This is the contents of my presentation. As we know, global warming has become one of the major challenges in today's world, and the emission of CO2 is the primary cause to it. So it is necessary for us to take steps to reduce the emission of CO2. Compared to the traditional techniques such as microscrubbing, membrane process is a cheaper and more efficient way. So it is necessary for the polymer membrane to be well in synthesis to be equipped for both high permeability and high selectivity. Also, it is important for us to care for the trade-off relation between the permeability and the selectivity and the stability of the membrane. The compaction under high pressure is one of the most important reasons for the membrane instability, permeability, and selectivity due to the decrease of the amount of free value. Now it is still a challenge for membranes to achieve requirement for industry syngas purification for the high temperature and high pressure. However, in the incorporation of MWNTS within the PVA polymetrics, which will contain amines as CO2, may be a potential method to solve the instability problem caused by the membrane compaction. The primary aim of the research is to synthesize a new kind of membrane with facilitating transport for CO2 hydrogen separation at high temperature and high pressure. We will incorporate the new mixed metric membrane by incorporating the dispersion MWNTS within the cross-linked PVA polymetrics, which will contain amine as the CO2 carriers. We hope this kind of new membrane can display better transport performance and strengthen resistance to membrane compaction under high pressure. We will use the solution casting techniques to synthesize the new kind of membrane. We will add the MWNTS dispersion and the cross-link the PVA solution and amine carriers to get the casting solution, and use knife casting and curing to get the 3 layers composite membrane. For the characterization part, we will use FTIR to get the chemical structure of the new membrane. You use the UV test to test whether the MWNTS has been incorporated, and use the SEM to get the morphology of the cross-link of the membrane, so we will get the thickness of the membrane. For the measurement part, we will use the gas permeation apertures for the measurement of the membrane transfer performance. Use the syngas as the fixed gas and use the argon as the sweep gas, and get the GC data to test the instability, permeability, and selectivity of the membrane. The final part, we will use the scale-up machine to make the membrane from the lab scale to the kilo scale, so it will have the chance to be used for the industry. For the expected results, we hope that we can get a membrane have CO2 high CO2 permeance, high CO2 hydrogen selectivity, and good stability, especially compared to the mixed metric membrane without MWNTS. For the significance, we hope that it will have the possibility to be used for the industry syngas purification. Also, it will have the chance to be used for either for the energy efficient pre-combustion carbon capture, or in conjunction with the water-gas shift reaction for CO cleanup to produce the high purity hydrogen. That's all. This is my reference, and thank you.